is called conductors. Give me examples of conductors.
Teacher,
Metal.
paper, wire.
Metal,
Plastic.
copper, wire.
Ma'am, metals. Copper.
Teacher,
Yeah, metal.
steel,
Copper is a metal.
iron.
Steel, iron, very good. Steel, iron, so all these come under metal categories, okay? And whereas materials, okay, give me examples.
Teacher, wood, plastic,
So, teacher,
Wood,
plastic,
plastic,
wood, rubber,
and
rubber,
teacher, paper.
glass,
All that, yes.
and
So,
glass.
yes. So all that are insulators. So things that doesn't allow. Okay, now so water is a good conductor or is it an insulator?
Conductor.
How many of you tell it's a conductor? Raise your hand. How many of you tell me water is a conductor? Okay, how many of you tell me it's an insulator? Okay, Sritej, why do you think water is an insulator?
Ma'am, like usually when water falls on electricity, it get electric shocks, but I'm not exactly sure if it's an insulator.
Okay, if you're getting electric shock means it is allowing electricity to pass through it, which means it is a conductor. Okay, so why the main job of the insulator itself is to prevent shock, right? So you have your answer there. If water is allowing electric shock, it means it is a conductor. Okay, so that is why they tell you not to turn the light switches on or play with electric appliances when your hands are wet, because water is a conductor. And even must have even seen it in movies or anything. If a person gets electric shock, they just hit the person with a wood. Why is that? Because electricity does not pass through the wood. Okay, and it insulates the electric current. Is this clear?
Yes,
Yes.
teacher.
Ma'am, I have a doubt.
Yes, Da.
So sometimes if you touch something, you get shocks, right? So is our hand a conductor?
Yes, because our body, the skin is a conductor. Inside the skin, we have blood flowing through it. So it is a conductor. Okay.
Okay.
Ma'am, are all the liquids are conductors?
It depends, because there are liquids that is in metal form. You know, metals can be melted into liquids, right? So you cannot say all liquids are conductors.
Okay.
Okay. Is oil a conductor or an insulator?
Ma'am, conductor.
It's a conductor.
It is not.
How many of you tell me it's a conductor? Raise your hand. One, okay, just raise your hand. 1 minute, I'll be back. I'm just getting a call just a minute. Hello.
Okay.
Yes, sorry guys, was an important call. Again, how many of you think it is a conductor? Raise your hand. Oil is a conductor. Oil is an insulator. Okay. Aishwarya and Rishit, you guys think oil is a conductor or an insulator?
Ma'am, oil is an insulator, ma'am.
Okay. All right. Yes, it is an insulator because of its varying in density. You know, it floats when it's mixed with water. Okay, so it's more thick and it is an insulator. All right. Now, there are different
Ma'am?
types. Yes.
What an doubt.
Yes, Da.
Ma'am, like when we drink in a water, like the filter water, so it from that the electricity can pass. So inside our stomach there is like a electricity, sorry, an acid. So will it stop the all the that electricity?
First of all, your first assumption itself is wrong. When we are filtering water, who told you electricity will pass through water? It will not pass through water. We are not drinking electric water. We'll die. That's not possible. The filter is just, this is like just a machine. This is a filter.
Teacher, can you scroll down?
1 minute. I told you do not write when I'm teaching in class. I'll be giving you time to write, only then you should write. Now this is a water filter, for example. Now this water filter is having a battery behind it. Okay. This battery is just an engine that allows this mechanism of water being filtered and everything. Now you take your fridge. You know your fridge remains cool only if there is electricity. It doesn't mean all our food that we keep inside are electrified. It's just something that keeps our food cold. Similarly, it's just something that allows water to flow through the machine. That's it. It is not electrified and all. Okay, Advika.
Okay.
And I think it's Hridesh. Hridesh, please don't write anything when I'm teaching in class.
I'm not writing.
Yeah. Okay. So there are two types of circuits. Okay. So this is a simple circuit that I actually taught you all. Circuits are classified. You know that circuit is nothing but a closed path of electric current. So there are different types of circuits. Okay. Now you all must have noticed. You know that if you your room switch, you're turning it off. Will the hall switch go off?
No, ma'am.
No.
No, ma'am.
Now you're turning the fan off. Does the fridge go off?
No, ma'am.
So you know that each of these are connected separately. Okay, each of these are connected separately. Now, for example, take these. You know, there are these lights that is fixed over a Christmas tree, for example. Okay. Now this light over a Christmas tree, have you all noticed one bulb goes off, everything goes off? Have you all noticed it?
Because they're attached to each other.
Yes, they're attached to each other. So every bulb is connected to each other. Okay. So depending on the connectivity of appliances, circuits are classified into series circuit and parallel circuit. Okay. So the first thing is series circuits. Okay. So a series circuit is nothing but it is in which number of resistances are linked one after another. Basically, a Christmas bulb. Okay. So each device, resistance is nothing but a device. Okay. So each device is linked to one after the another. Such connections is also termed as end-to-end connections, or it's also called as cascade connection. Okay, there is a single path for the flow of current. Okay.
Ma'am?
Yes.
Ma'am, does an extension box come under series circuits?
Yes. No, sorry. An extension box, for example, your lights are very short. So sometimes they add an extension box in order to add more lights. Okay, so this can actually be cut off and added to another extension box in order for this to work, but you cannot do anything with this. Okay, so single path for flow of current. And numerous resistances are linked one after another. Resistance is nothing but appliance. Okay, so this is also called as cascade connection. Okay, this is what you need to know about series circuit. So what are the properties of these series circuit? So same current level will same current will travel through every resistance. Now, for example, you have a bulb here, you have a bulb here. So bulb A, B, C. Okay, each bulb is getting 5 watts of electric current. This will also get 5 watt. This will also get 5 watt. It's not like 5, 10, 15. So every appliance or every resistance is having equal distribution of electric current. So the same current travels through every resistance. And also the supply voltage is the total of the individual voltage. This is very important. It might be coming and asking sums. Okay, now instead of what's actually voltage, okay, now for example, okay, I mean, I'm not going to give you the sum. Let me see how your brains are working. Okay, so the next point is the supply voltage V is the total of the individual voltage. Okay, now I'll probably give you a sum, for example. So know that carefully, that each supply of voltage for each resistance is equal. Okay, keep that in mind. Now try to solve this problem. Okay.
Ma'am, 20.
Yeah, who said 20?
20, ma'am.
And 20 voltage.
Yes,
Ma'am,
20
Advika.
voltage.
Why is it 20 voltage?
Ma'am, because the 10 bulbs and
Ma'am, because each bulb
takes 2 watts of electricity.
Okay.
And if 10 bulbs takes all the 2 watts of electricity, it will become out to
Very good. So V1 plus V2 plus V3, so on till V10. is equals to Vn. Vn means total, okay? So 2 into 10 is 20 volts. Very good. So this is how you have to solve the sums. All right. So these are the properties of a series. So the equivalent resistance is equivalent to the total of the individual resistance. Okay. Now going to the second type of circuits, that is the parallel circuits.
Ma'am, what type of circuit is used for our computer?
Parallel circuit. That's what we're
Okay.
going to see. Okay. So a similar potential difference is it's similar to it, but there's only a single appliance. Okay. So similar potential difference gets across all the resistance in parallel. So the total current gets distributed into the number of paths. Okay. So basically how a laptop or a single refrigerator works. Okay.
Ma'am,
Yes.
ma'am, series circuit means which has so many like which work together, and parallel means which works singly.
Yes. Okay. So it's not that, for example, this is an electricity box, okay? This electricity is being supplied to devices, 1 device, 2 device, 3 device, 4 device. So if one device cuts off, all these devices cuts off. This is called what connection?
Parallel connection. So parallel
main
circuit.
connection.
Parallel connection.
No, ma'am.
And series.
Ma'am, series
circuit.
Ma'am, because they're
Series
connected.
circuit.
Ma'am, because they're connected together. So it's a series.
Yes, ma'am.
Series, because the one goes up, everything goes up. Now there is an electric supplier, but it is connected to many devices, but they're all of different parts. So if this goes off, these don't go off, they start working. This is called as parallel connection. Do you get the difference?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So the parallel circuit is one in which number of resistance are linked across one another in such a manner that one terminal of every resistance is connected to form a junction point. This is the junction point. Okay, so let me write the definition.
Ma'am, I have a doubt, ma'am.
1 minute, let me finish writing.
Okay.
So parallel circuit is the one in which numerous resistances, look at the diagram, numerous resistances are linked across one another. They are linked across one another in such a manner that one terminal of every resistance connects to one point to form a junction point, while the remaining end is also connected to another point. which is here. Got it? Is the definition clear?
Yes, ma'am.
Yes, teacher.
Okay, yes, Anvit, your doubt?
Yes, ma'am.
Yes, ma'am.
Yes.
Ma'am, but how does a computer command our parallel circuit?
Because if your computer goes off, your refrigerator or your TV doesn't go off. It is a separate device that is connected to the electric point. See, now for example, you're having your computer here. Okay. Now the electric socket is over here. But this socket is used to charge your phone also. Okay. Now, if your phone is getting switched off, your computer doesn't get switched off. You get it? Or if your computer switches off, your phone doesn't switch off. The electric supply, this is not taken into account. If this goes off, then everything goes off. Yes. But this is not taken into account. We're talking about the device shutting off. In a series circuit, if one device shuts off, every device shuts off. In parallel circuit, if one device shuts off, the other device will still be working. You got it? Is it clear, Anvit?
Yes, ma'am.
Okay, fine.
Yes, ma'am.
Now to the properties of parallel connection. So this is a bit more detailed. Okay, so that's not required. So your potential difference and all you will learn in the higher grades. Okay, so this much is enough for today. Please make note of it. Wait, I'll just bring it all closer so it'll be easier for you to note down. Yeah, please make note of it. And if there's any doubt, please ask me.
The French
Ma'am,
Yes, Da.
ma'am, can you zoom it a little?
Ada.
Ma'am, is there something below the parallel circuit?
No, Da, nothing else.
Oh,
Teacher, today no homework.
I will give you homework.
Teacher, tomorrow can I send an at this time?
Not today? Already your yesterday's and today's homework is pending. So I want your both homeworks after class. Tomorrow's
Teacher,
homework.
after class, actually, I'm going somewhere.
Fine, at least I need it by tomorrow morning, not later than that.
Teacher, tomorrow morning means school is there, teacher.
You done with your homework or you didn't do it?
No, teacher, last question is there of yesterday's homework. So I'll send it tomorrow after coming from school. Here 4:30 I will send.
Fine. Don't do it regularly next time, okay? Try to complete work on time.
ma'am, we should write the question. in a that thing in a Persian
Your
Christmas
wish.
tree of.
It's your wish, Ashwat. If you want, you can write it.
Okay, ma'am.
Mom, I'm done.
Okay.
Mom, only 2 questions in homework.
Yes.
Okay, ma'am.
Ma'am, I completed.
Okay. Who else is writing?
Ma'am, Sri
Ma'am, me.
And me, ma'am,
Ma'am,
I'm writing
I'm
page
good.
6.
Okay, right.
Done, ma'am.
Okay.
Ma'am,
Yeah.
ma'am will say to voltage or watts.
Voltage.
Okay, ma'am.
Ma'am, after we finish, we leave.
No, wait.
Teacher can
Ma'am, I'm done. Ma'am, this is Sritej, I'm done.
Ma'am, I'm done.
Who else is left?
I'm writing.
I'm writing the homework questions.
Okay, please make it quick.
Teacher, I'm done, teacher.
Okay.
Ma'am, should we leave?
No, da, wait.
Teacher, can we leave?
I told to wait.
Okay, teacher. Teacher,
Yes, da.
can you show homework part?
And this is Adrit, I'm done.
Okay, who else is
Not.
writing?
Teacher, can you little bit show homework part?
Yeah, da, it's clearly visible. Like the whole part is visible on the screen.
I can't see outside. Yes, teacher, now it's visible. Teacher, I have noted homework also.
Who is still writing?
Ma'am.
Only one person? Which part are you writing, da?
Ma'am, I am the parallel circuit.
Then you're not done with you're done with series?
Yes, ma'am.
Okay. Make it quick, Ashwath. Or just take a picture of it because you're the only person who's left.